Good morning, everybody. Welcome to the Future of AI Horizons panel here at the Computing Futures Symposium. I'm Bob Bond from MIT's Lincoln Laboratory. I'm privileged to be your moderator today for what promises to be a rich and inspiring conversation. I have a bit of a script here that I'm going to go through, but before I do that, I've just been noticing like AI is everywhere, right? It's ubiquitous. In fact, I even recently heard that it's infiltrated the bakery industry, and they've come up with an intelligent Oreo, and apparently it's one smart cookie. So I just wanted to set the level. And I didn't write that down because I was afraid if I did, they wouldn't invite me to be the moderator. So anyway, to continue with the script. I believe it's no exaggeration to say that we're in the midst of the age of artificial intelligence, AI, and it's just beginning. We've arrived at this current juncture today propelled by the engine of innovation that is American academia, you all. An engine that's been fueled by the visionary partnership between universities, the US government, and industry for over 75 years now. Looking to the future, AI will have a progressively wider and more profound impact on day-to-day life, social and political institutions, the internet, business operations across all sectors, national security, education, and virtually all science and technology advancements. In today's AI panel, we will be diving into where AI innovation is headed and the importance of future research, so visionary future research, that aligns with pressing national and societal challenges. Indeed, we're incredibly lucky to be joined by 4 experts from leading AI research institutes, each bringing a unique yet complementary perspective on the future of AI. So the format that I'm going to follow here is I'm going to introduce each of our panelists very briefly, and then I'm going to ask each of them for a couple of opening remarks. 3 minutes each, so we have to try to stay on time. Oh, the timer hasn't started yet, so we still have an hour. And after that, I'm going to circle back and ask each of them some prepared questions that I've come up in talking, that I've come up with while talking with them and finding out what their interests are in, contributing to this panel. And then hopefully we'll have about 15 or 20 minutes to open up questions to the audience, and then we'll have a few wrap-up statements at the end, and then I'll summarize. So to introduce our panel, we have Professor Yolanda Gill from USC, who is the past AAAI president and is the co-chair of the CCC AI roadmap that you heard about earlier today. It was, I guess, published around 2019 or so. We have Bart Selman, who is Professor Bart Selman from Cornell, who is the current president of the AAAI and a leader in AI ethics and policy. We have Professor David Jensen, who is from UMass Amherst, professor at UMass Amherst, and he's the chair of the CCC Task Force on AI Research Futures. And at the end of the table here, we have Professor Aarti Singh from Carnegie Mellon University, who is the director of the AI Institute for Societal Decision Making. And so what I would like to do is invite each of them. So I'd like to begin by asking each panelist to share some idea or a vision that's guiding their current work and that they believe is going to play a key role in the future horizons of AI. And I'll start at the end of the table with Professor Singh, and we'll work back towards me. Go ahead, please.
Sounds good. Hi, everyone. Can you hear me okay? Yes. All right. Now, maybe. So yeah, we are at a great juncture in AI. It's really exciting, but also I think a lot of responsibility in the sense that over the years that AI has developed, we have focused a lot on prediction, right? Accuracy of the models. And unfortunately, to a large extent, a lot of the papers being published today still focus on that. And I think what we need, again, thinking of the horizons, is a shift, which we are starting to see a little bit, in not just doing better in terms of predictions, but actually developing algorithms that think of the consequences, the downstream decisions that the AI predictions influence, who it impacts, and developing AI that can actually takes that into account from the beginning, right? So a lot of effort has been so far, and it's great to have that. And we are starting to investigate things like maybe explainability, trust, and so on. But I think we lack a lot behind in that sense. For example, one thing we often fail to realize is that AI can lie, right? We can come up with all the reasoning, explainability, and build those capabilities. It could be using a completely different reasoning and tell you something else, right? So that's just an example to say we have a long way to go. And thinking about who the decisions will influence, the humans in the loop, I think is really important. It leads to technical challenges, such as how do we combine information that's gathered using lots and lots of data to train these very large foundational models with domain-specific applications of it, where now you have to engage with you have to take the innovation, you have to take the build a great knowledge base we have built and combine it with domain-specific knowledge and human-provided feedback, right? And the data there is not as large, right? We have to think about humans labeling or providing feedback on a few things. How do we integrate that with this big knowledge base and make the AI downstream consequences really relevant? And I'll just end by saying that to me, it seems like this really needs, and in my research I've been trying to do that, a great partnership between government, academia, driving some of the innovation, industry enabling the applicability, but also a lot of societal domains don't have market forces driving them. Our institute works on disaster management as a use case, right? Another one is health policies. And really in these cases, sometimes you really need this partnership to make things happen because of the lack of market forces. And I think this triad needs to come together to make it work.
Thank you, Professor Singh. So, I mean, thinking of AI in the context of systems, and that it's not just a model, but it's a model or a set of models working together for a purpose, and then how to evaluate it within that context. Professor Jensen.
That rumbling we're hearing is the future of AI coming our way. So one of the reasons that that I'm here today is because I am heading up this task force right now with the CCC on AI research futures. And the idea for the task force came along because there was this perception that we had that mostly is outside of the computing community, that AI is kind of done, all but the scaling. And it's ready just to be sort of pushed out to industry, and industry is going to handle the rest of it. And one of the things that we're trying to emphasize as we've been doing our work is that there's a current paradigm, there have been past paradigms, and there are going to be future paradigms of AI research. And that one of the consistent problems that all sciences have is that the current paradigm always seems like the final one, because we tend to focus on how to exploit that particular paradigm, and we kind of are blind to or choose to ignore the things that it doesn't do particularly well, and the things that are going to be the seeds for the shift to whatever the next paradigm of research is. And so what we're trying to do is to envision alternative futures, not expecting that we're going to pick the winner, that we're going to say this is right, but to say there are places to go that are very important, that address various kinds of things that the current paradigm of AI research around large language models and deep networks may not be doing particularly well. So some examples of those are things like quantum AI, embodied AI, neuro-symbolic AI, neuromorphic computing. These are examples. Again, we're not saying that one of these is going to be it or that any one of those is going to be it. But the idea is to try to say there are important futures for AI research, and that predominantly those paradigm shifts come out of work that is both in industry and in academia, because it's people who look and say the current structure isn't quite right, often are kind of dismissed, and then later it turns out, just like the current paradigm, that this is really an important and profitable way to pursue AI. So those are my thoughts.
Thank you, Professor Selman. So let's prepare for change. Professor Selman?
Yeah. So just actually following up somewhat on what David just introduced. I'm part of the AAAI, and we have the AAAI conference, and we sort of reflect on how the field is moving. One of the most interesting aspects we're seeing is what I refer to as the reintegration of our field. So AI was over the past few decades had all kinds of subfields: natural language understanding, computer vision, machine learning, reasoning, knowledge representation, planning, multi-agent systems. These were becoming separate communities with their own conferences. I think what is really exciting now, actually, and you see that at the AAAI conference, is these subfields are being reintegrated. So the obvious examples are multimodal model, where you combine language and computer vision, but there's also reasoning and decision-making integrated with machine learning. And planning, for example. So the community, and this follows up what Professor Jensen's comment, is there's still many different aspects of intelligent systems or cognition that need to be conquered, but in my mind, it will be conquered by this integration. So almost all this work that you see at AAAI now, or lots of the work leverages from, for example, large language models capabilities, but it extends them and adds to them. My own area, reasoning and planning, there's this discussion, well, do LLMs reason, do LLMs plan? How good are they at planning? And what we're seeing basically is they provide certain kinds of planning. For example, an LLM is very good at giving you, if you give it a high-level goal, it can give you sub-goals to achieve. It's not so good at fitting all the little steps together to reach the sub-goals. More traditional planning algorithms are very good at that. So we can combine those capabilities from other techniques from AI with the current LLM methods, and I think that's super promising. And I believe this reintegration of our field will drive to very useful systems. Final comment is that what is another exciting development, I think, is the application of AI to scientific discovery, mathematical discovery. This is where our universities, academia, have tremendous opportunity. If you look at Cornell, we have experts in material science, in physics, applied physics, in mechanical engineering. And what we're seeing with these programs that are partly actually privately funded now by the Smith Foundation, to bring AI to these other areas. So we're going to see an acceleration of scientific discovery and of engineering methods, of mathematics, thanks to AI. But it really has to involve these domain disciplines. So we can't really, as an AI community, we don't have the domain expertise. But when you bring the AI expert together with the domain expertise, which you have in all the different departments, you get a very exciting combination. So I think that we'll see a lot of activities around accelerating scientific discovery and engineering methods using AI.
Thank you, Professor Selman. And Professor Gill, I'll hand it over to you now.
I think the field of AI has always been exciting to me, but I love coming to meetings and seeing the interest, especially for the younger generations. Always, I think as a community, we're generating so many ideas, and it's a very vibrant field. I think a lot of it is imagining new techniques for AI. But also there's a lot of people working on more experimental research and really caring about the impact of AI. And that is where I see the most excitement. And I will say that the short-term impact of AI is very, very interdisciplinary. So I do research in AI and science, and I am very excited about all the foundation models for science that are coming out. These foundation models use large amounts of science data. Scientists are excited because they seem to capture a lot more knowledge than it's possible with other empirical models. The papers have many authors, mostly from universities, sometimes also from industry, but it's really great to see that collaboration and those large teams of people developing AI models for science. So I think that we will see a lot of impact, particularly in medicine. There's a lot of interesting foundation models coming out there. Similarly, for other AI verticals, we'll see more applications of AI that include communication and language and reasoning, but also agents, tasks, monitoring, plan repair, replanning, collaboration. So all of these capabilities together. And I think, when Aarti is talking about the decision and the long-term consequences, that starts to speak for this kind of vertical integrated way to looking at the problem. And I think that we need to work a lot with other disciplines in these areas, social sciences most notably. And lastly, another exciting area that I see is this connection between the software and the hardware. So I think we don't do enough collaborations in that space. I am excited to see my colleagues put new materials on top of silicon and make the memory super fast. I am excited to learn about high bandwidth memory and different approaches. I'm excited to hear about quantum communication. So I think a lot of interesting things are going to come out of that, but we have to connect more with the AI research and the algorithms work that we do. And that's in collaboration with engineers, electrical, materials, etc. So I'm excited about this impact that interdisciplinary AI can have in the short term.
Thank you, Yolanda. So kind of integrating across what I've just heard, what we can look forward to in the future is a reintegration of multiple fields of AI. Expect it to be reintegrated in some novel and some way that we should be preparing ourselves for, but it's hard to prepare for novelty. It will manifest itself in the human context and in the system of system context, and will pull in broadly from society and from the science and technology world interdisciplinary skills to make it happen. And so I think that's the vision that we're seeing being painted for us for the future here. So I'm going to turn now to some questions that we've prepared, some moderator questions. And I think I'd like to direct my first question to Yolanda Gill, Professor Gill. So, Professor Gill, a 20-year research roadmap for AI was released in 2019, which is a long time ago in AI years. And so, if you had the opportunity, how would you update it today?
That was an exciting exercise. It was led by CCC and AAAI. We engaged the community in various workshops, town halls, open requests for comments. So it's it reflects the community thinking about the next 20 years of research in AI. And looking back to it, Bart and I co-chaired that effort. Looking back to it, I can say proudly that the community, the AI and the computer science community, were very visionary in terms of the 20-year out challenges for AI. So I read back the document, and all of that still stands. So despite the advances and the excitement that we have in the technologies that we have in AI today compared to 2019, those research areas still stand. So one area we emphasized was integrated intelligence. How do we integrate different intelligent capabilities into a whole, this system of systems idea for intelligence? A second big area, we talked about meaningful interaction. How can we interact with AI and delegate, rely on it, be able to convey what we want and how we want those tasks to be done? We still don't have that. And the third area was self-aware learning systems that realize I need to change what I know. I need to set up a new learning task and update myself. So all of those still stand. Even back in 2019, we pointed out the tremendous investments in AI that were being made in other countries internationally. So the EU, the UK, the Netherlands, China at the time. Today we would add many others, Singapore, Saudi Arabia, we saw yesterday in the news. So, but I think that what we were saying about the importance of AI for the country's future and the innovation that it can bring to all areas still very much stands.
Interesting. So, did the report anticipate large language models at all?
We did not anticipate that. We did not anticipate the rebirth of reinforcement learning. We did not anticipate a lot of things. But I think the point of it was not what's next, but what needs to happen in the long term in the field. And
right.
I think that's the interesting things that will last 15 more years, I think.
Yeah, so I think the research thrusts that you articulated are still going full steam and more. And they're going in novel ways, which is what I think David Jensen was also alluding to. Let me move on to Professor Selman. You were also, along with Professor Gill, you were a co-chair for that roadmap. Do you have anything you'd like to add about what you might have changed if you were doing it today?
Yeah, so what I think Yolanda's right that the themes we set up were correct. I think what large language models have brought us is an acceleration in all these areas. So, agentic systems and integrated systems, things are going much faster than we thought. And I think what large language models brought us is there was the general sense that natural language understanding would still be 15, 20 years, 30 years out. The transformer model and ChatGPT, the development in that area really were surprising to the community, to literally almost everyone, including the people like Jeff Hinton, the inventors of deep learning themselves. And so what we see, but I view that as basically acceleration. So what large language models allow us to do is bridge natural language with the more formal languages like logic, programming languages, and the large language models, build a bridge between these paradigms. So now we are able to take techniques that were developed for AI planning, say, or for reasoning, and link them to human language and human understandable statements, and the language models can provide the translation. So to me, we've seen incredible acceleration, but the themes are still very relevant. Yeah.
Right. So, so that's, I would say, a testament to the vision that went into forming that roadmap, 6 years ago now, 7 years ago now. Your comments on LLMs suggest to me a whole set of questions. I know we don't have time to go into all of them, but so where do you, Bart, see these models in, say, 10 years from now? And before you answer that, so we've had, DeepSeek's R1 came out recently, and what does that mean to us? That's one dot on a curve, but is it what's the significance of that?
Yeah, so as an academic, I was actually very excited to see DeepSeek. When we did the report, we noted that China at that time, this was around 2015, they set up a plan to train their own AI researchers and workforce. DeepSeek is actually a result of that. So it's done by a small group of people that did not stayed within China and got their AI education there. So that roadmap that they laid out for building an AI workforce and AI experts really did work out, and we actually highlighted in the report those kind of developments. What I like about DeepSeek is that it shows, to me, there's often the question like how relevant is academic research, how relevant, especially when the general public gets the idea that AI research is done by Google, by Facebook, Microsoft. But that's actually misleading. I think that what DeepSeek shows is like a large company, they have resources, so they all at some point said we need bigger and bigger and bigger models with more and more and more data, and that's the only path forward. Then DeepSeek comes around and says, no, you can actually, with a smaller model and less data, but trained in a different way, you can match or possibly in certain areas even exceed performance. So what I think is going to happen over the next 10 years is we'll see more of those somewhat surprising advances, because for example, I study mathematical reasoning and scientific reasoning with large language models. They're not there yet. We can, it's sort of interesting. They can look very good at certain tests and at certain math competitions and things like that. But everybody in this room can outperform them on fairly basic discrete math problems. And so we know there are some shortcomings there. I think academia will actually now figure out how to fix that with small teams finding new ways of enhancing their capabilities.
So that's very interesting. So it kind of points to a real meaty role for academia in shaping the large language and foundation models of the future, which I think is I totally agree with, and I think that's great. I want to move on to Professor Jensen, since we're talking a little bit about LLMs. You observe that the history of AI is one of new paradigms emerging that augment or even potentially supplant past approaches. Yet, it can be difficult to appreciate, how some unexpected scientific advances, how unexpected they can be. So, how far in advance do you think we actually anticipated, or did we see LLMs coming down the road?
Yeah, as has already been alluded to, this was a surprise to a large number of people, including people who were very deeply knowledgeable, in how deep networks function and how to do natural language processing. So, I think it's a great example of how there can be real surprise, even in the technical capabilities of a system that was, where the learning algorithms were well known and developed, but the capabilities of the resulting system were quite a surprise. Now, I think there's also a sort of expectation of we're going to go on having exactly those surprises by exactly those methods, and I'm less certain about that. I think we've got some evidence that the simple approaches of just, more data, larger models is not producing what we want, and instead there need to be innovations in how we train those models and maybe even what kinds of models we're using.
Or how we produce the data that we train the models on.
Yeah, absolutely. Right. I also just want to quickly point out, Yolanda and Bart, I think, are modest about the, how good that 20-year roadmap was. One of the things I love about that roadmap is that it sets out a set of tasks, of things we want AI to do. And having that out there that says, here's the range of things that we want AI systems to do, keeps us honest in a certain sort of way. We tend to focus down on what current methods can do because we want to exploit those capabilities, and having that breadth is just such a gift to the field to say, here's the range of things we want.
Yeah, I think that actually is almost the theme of the CCC, right? Is that broader visioning, that longer term visioning. So I had mentioned in my introductory remarks the sort of historically powerful triad of academia, U.S. government, and industry. And I'd first like to direct this question to Professor Singh and then open it up more broadly. But I was wondering, Professor, can you give an example of where AI-supported decisions are achieving societal impact, where it wouldn't be possible without this partnership? And also to follow up on that, so what, in your view, does a well-functioning, societally impactful partnership between academia, government, and industry look like? And so if you could comment on those two questions.
Yeah, so certainly coming from our institute's perspective, like one of the things we're working on, as I said, is AI for disaster management, right? And that's a space where you have to start, AI is not used in disasters, right? You have to start by talking to the people involved in this, which is government agencies. We work with Florida, Department of Emergency Management. We recently did a tabletop exercise just a couple of weeks ago with them. Similarly with Pennsylvania and Texas, so many state emergency departments to understand what are their needs, are there pain points where AI should be plugged in? And this is a bigger point. Very often we develop AI and later think about how to apply it. But if you really have to make an impact, I think you have to start by talking to the people, right, where the domain that you are trying to make an impact in on their needs. Sometimes AI does not make sense. It's not the right solution. And that's exactly the kind of things that are coming out of these discussions. They tell us, we don't need AI for helping support us in language, for example, right? But they need AI in creating the situational awareness. So these discussions are very important. A lot of the innovation is still coming from the academia on how to then develop models that are adapted to their needs and so on. But at the same time, I think industry also has a role to play. In our case, actually, it's not, of course, there are the big giants doing the AI development and exploiting, as you said, the existing technologies. But in this space, in the disaster space, I'm talking about industries like American Red Cross, right? Like they are a nonprofit. They are also an industry, right? But we talked to them and we figured out the way they were doing training of these volunteers was by literally a physical board game that they make them play, right? That's the current standard on how they do training. So we talked to them about, and they really they said, could you, maybe digitize this game for us? We were really hurt during the pandemic. It was hard to do the training. But even otherwise, when they train on this physical board game, it's a single scenario that's presented to them, right? So we would like to be able to present different scenarios, create simulators for that, and also maybe use some AI tools that can make recommendations or create that situational awareness. So we are working with them on that. And that's, I think, to me, a great example of research that's really inspired by the domain, but also we identified great opportunities to develop this platform that can be used to study broadly AI, recommendation algorithms, human AI complementarity, as well as cognitive models of human decision-making under stress and time pressure. So I think that's one example. And maybe I'll just say one more point. Another really important aspect of working with all of these is that our students, especially the AI students, are getting training in soft skills that they otherwise don't. And I think that, to me, is another thing that probably is presented as a roadmap, but you can strengthen more, that our students know how to do math, they can prove great theorems, come up with great algorithms, but can they talk to people in the domain and really translate the impact of what they are doing into practice? They don't have to do it themselves. Sometimes I tell my students, it's not like I'm asking you to not do theory, right? But you have to be able to talk to somebody else who cares about the application and help translate your methods. So, and I think this triad is actually really helping us give that training to students.
Anyone else from the panel like to comment on this area in general?
I guess maybe briefly, we did raise it also in the roadmap. This working between industry, academia, and government is very important. We also think AI has sort of tremendous opportunities to improve education, to improve healthcare, certain kinds of areas that are less commercially interesting, possibly, or not the highest priority, but are very important for the country. So I think actually, having active collaborations between academics, industry, and government labs would be very useful to tackle things that are not immediately commercially relevant, but would be a great thing for the general public.
Thank you, Bart. So I'm going to move on. I really want to give the audience a chance to ask some questions. I have one last question before I invite input from the audience. So I'm reminded of a cartoon I saw once where there was a big white elephant lying on a psychiatrist's couch with its feet in the air, and it had a rather distressed look on its face. And it's saying to the analyst sitting nearby who was holding this notepad, it's saying, and what's worse, sometimes it's as if I'm not even there. So now, the white elephant that I want to talk about is a visionary white elephant. It's like looking out to the future, and I think it fits into this category. And it's the whole area of artificial general intelligence, or maybe even more controversially, the area of artificial superintelligence. And the question, is this on the near-in horizon? And what does near even mean in this context? And if AGI is still far out, do we have the knowledge today, or are there some fundamental missing ingredients that must be discovered and combined to get to AGI? Indeed, is the quest for AGI today a quest that, has driven AI research and development even before the term AI was coined in 1956? Is it more of a distraction that we should steer clear of, given all the more immediate societal benefits and challenges that we're facing today, as well as the R&D needs and opportunities that are evident in our AI du jour? So that's a long statement, but put simply to the panelists, would you mind sharing briefly, because I used up all your time, your thoughts on AGI and its importance in shaping our current R&D agenda as we move towards the future of the future horizons of AI? And who would like to start talking about what they think about AGI? Bart.
It's a fun topic. So I think the discussion. What do we have?
And you have a minute, by the way.
Huh? How many minutes? I have half an hour. Okay.
That's not the Bart Selman timer.
I give myself extra time. Now I forgot what I was going to say. No, so basically, AGI, it's sort of presented as a yes/no kind of question, whether we'll have it, when we'll have it. I look at the capabilities of large language models, and especially if you put them in agentic systems, as quite fascinating in the sense that, yes, there are still things missing, like reflection or introspection, but there are other parts of models that are already sort of beyond, that we do not fully understand, and could actually be called, very intelligent. I like to tell my students there is no human, like if you take the classes at Cornell, ChatGPT or the latest model can pass all courses at Cornell, all exams, roughly at the B+ level. So there's no human that has that broad an understanding of psychology, language, art, science, engineering. So in some sense, these large language models already bring capabilities that are novel, and I don't know quite what to call them, but they already bring something new, a kind of cognition that we have not seen, and maybe non-human. So I don't think it's going to be something that is at some point we have achieved AGI or at some point in time. It will be more like, these models are going to be more and more interesting from a cognitive perspective, and get capabilities that we are going to be surprised by as humans. And I would argue that's already somewhat the case. So.
Interesting. Would anyone else like to? Yes. Go ahead, Professor Jensen.
So the first thing I'll say is that I think it's important to consider whether the sort of human metaphor that AGI has embedded within it is the right one to use. So there's a very good article that showed up recently in Science, Farrell, Gopnik, and Shalizi, that says large language models are social technologies. All right, they're social and cultural technologies.
It's a great article, by the way. You should all read it, at least.
Yeah, highly recommended. And it's interesting, one, because it is a concrete alternative metaphor for how we should think about these technologies, but also it is itself, I think, says there are alternative ways of looking at it, and it kind of reminds us that the whole AGI framing says we are the models, the only interesting model to compare a technology to, and we should be suspicious of that. Second thing I want to say is that there are very deep evaluation challenges for the current generation of large language models and other foundation models that are still being worked out. They pose some of the biggest challenges to science that I think any field has faced. A whole range of challenges of doing good science on those and really understanding what they're doing. And the final thing is we don't know what's going on inside. And in the small number of cases where we have figured out how a particular piece of reasoning is done, we're often not impressed because they're sort of they're grab bags of heuristics that cover most of the cases, but not all of them. So I think there's a bunch of reasons to be fairly skeptical and sort of step back a little bit when we use that analogy.
Thank you. Yolanda or Aarti?
I'll say Aarti will be better at prediction. It's her job, but I'm very bad at predicting AI futures. I met my husband in graduate school. He did a PhD thesis in machine translation. And at the time, I remember telling him, I feel so sorry for you. You're working in a problem that you're just not going to be able to live to see it resolved. I said those words. I feel sorry for you. Fast forward 20 years, he had a large group and was able to create machine translation systems that were statistical and spun off a company and became a millionaire. And these systems are used very widely. And
you're not feeling as sorry anymore?
One of the people in his group went to found Google Translate. So the problem is not as insurmountable as I thought. So I'm terrible at this. But I'm always happy to be surprised. I don't mind being wrong and not feeling sorry.
Great. Aarti?
Yeah, so I won't predict, but I would just say, to me, it feels like it's actually not a good goal to focus on, the superintelligence. It's a good proxy goal, but if there's a technology that can, really supersede, human intelligence and all of that, it's no good unless it can assist us in some way. So to me, the real focus should be assistive technologies and not superintelligence. It's a good proxy goal, but not.
Right. Thank you. That's a wonderful close to this. I kind of follow your same sentiment in that regard, which is why I think it's a great close. So I'd like to open up the questions to the audience now. If you just line up and then tell me your name and association. We'll start at the front here.
Sure. I'm Jovish K. I'm at Wells Fargo. Thank you all for a thoughtful panel. I want to build off your last question, Robert, which is this question about if we move towards this future of AGI. And I was thinking about that thing that Lisa said towards the end of her talk when she was saying that in the future we're going to see AI building into the research of doing AI, right? And thinking about how do we influence the future, and this realization that programming these bots, that changing the opinions of these AIs that are going to be making decisions, that are going to be agentic in the future, is going to look more like techniques of influence, of propaganda, of persuasion, of marketing, than it is, the sort of like for loops that Holly was talking about, that we all learnt in programming. So with that vision, how are we going to be able to change the future of AI if more and more of it is being written by the AIs themselves? Short answers, please. Just nice, easy.
Hey, that's my job.
All right. Low ball, softball question.
Who would like to address that very important question?
I can give it a try. I think you raise an important issue. Is sort of what if the systems become autonomous and start doing agentic work. I think that's why. I think it's important for us to as a research community to actually think of some of those challenges and think on this. It goes by the name of AI safety. I do think that we can do reasonable things, that we haven't actually studied that carefully. Some people are starting to study it. Some people are starting to ask the question, can we put certain boundaries around these systems and ensure that their values are aligned with human values? I've seen some work that gives me hope that we actually can address it, but I would also stress that the community, the research community, should not ignore these questions. So there's somewhat of an open-ended answer, but yeah.
All right, let's move on. Back mic, first person.
So, Brad Imony at San Diego National Labs. I want to ask a question about this explore-exploit balance that you all alluded to, and in particular, we have this emphasis on LLMs right now, which I think, when we talk, there's kind of an implicit assumption that in 5 years there might be something different, because every 5 years there's been something completely different. But I think we're seeing also right now that there's a level of capital investments in hardware, data centers, data acquisition, everything to enable LLMs at scale. And I guess one of the concerns I have as someone who's doing, future brain-inspired AI algorithms is, are we inadvertently creating barriers to entry for new technologies and new applications that may not fall under the transformer LLM umbrella? And are we risking, doing the similar thing that happened in the airline industry, where 737s have been around for 50, 60 years, and there's really not much innovation along the, there's better, it's better, but it's incremental, right? We kind of saturated flight decades ago. And are we at risk of doing that here without knowing it?
Interesting.
It's a great question. Sorry.
Go ahead, Yolanda.
It's a great question. The world is moving in a way that is really out of our control as researchers, right? A lot of money is moving the world. A lot of things that you hear about AI are things that people want you to hear, things that amplify, things that convey a certain message that people want you to hear. So I tend to read everything that I read about AI with a grain of salt. Do not let every channel that comes to you amplify itself to make you believe that that's the world that we live in. That would be one part of my answer. I believe so much in the research community. I have no doubt that I will continue to be surprised and wrong when I predict we cannot do something. And I am absolutely convinced that as new ideas come out and new technologies come out, they will prevail and they will be successful. So I am a tremendous optimist about this technology.
Yes, front mic.
Hi, Mutahara from Carnegie Mellon University. Thanks for all sharing the interesting insights. I have a kind of a big picture question. What is AI research? So the reason I'm asking is that we've been trying to figure that out, talking with a lot of researchers who has doing something with AI, and no one agrees what is AI research. I think the only thing people agree is the foundational core theoretical AI research, but people who are working on human-robot interaction, some people say, no, you are just using AI to do something. You're not doing AI research. I'm doing a lot of responsible AI research, and people said, no, you're just doing research on AI, but that's not AI. And my question is that what's going to happen with the community? Because now everyone tries to say, I'm doing AI research because that's the hype, right? But then some people say, no, you're not doing AI research. Where were you when AI was like in the winter time of itself? And my question is that even important? And one reason that it could be important is the funding, right? And then how we're going to sell it. But then some communities are much harder to get funding right now, or responsible AI, now that the administration is starting to focus on innovation versus regulation and safety. What do you think we should do as a community? Should we define AI research and put everyone under one umbrella and help each other? Or we should still stay with AI research as foundational research and the rest is just circumstantial? Thank you.
Yeah, so actually, when we did the roadmap, we were struggling with random groups of people who suddenly said, we do AI research and we need that funding. I think it has to, in the end, what AI research is, it has to be driven by the problems and whether the problems are interesting. So I wouldn't want to constrict, I wouldn't even want us to define what AI research is. I know that when many decades ago, I went into AI, I wanted to understand human cognition, human decision making, and I let that guide my research. If your interest is in safety or fair AI, then those, as long as the questions are interesting, I think that then it's fine. You might have to change your messaging a little bit for the grant proposals. But so I think it should be driven by what are the interesting questions. And I must say that one big change I see at university now is AI had become really machine learning, and it's sort of refreshing to see people now talking about reasoning and planning like it's something new. No, I guess, yeah. But as long as it's driven by open questions, I think the research will find its way. So,
if I may very quickly, I think that the field of AI has become kind of what health is. So there's the neurosurgeons, there's the other surgeons, there's the people that give you vitamins, there's the people that do counseling. As long as it benefits some patient, that's really important. Thank you.
And if I can just add one more thing, which is there's a reason there are no departments and no PhD in AI. And at CMU, we have been at the forefront of defining any new, degree department that made sense. And there's a reason we don't, which is, I think it would be a mistake to do that. It is just a very broad field, and a lot of people can contribute to it. And I think it's, in some sense, it has similarities to data science. When people started thinking about, should we have a department, college of data science or something, it doesn't make sense. It's very broad. And I agree with that sentiment that a lot of disciplines get very helpful.
Hey there, Bill Regley, long-time listener, first-time caller, University of Rome. Two things. One is advertisement for tomorrow's panel that I happen to be chairing, where Henry Farrell is one of the participants in the panel, the author of the paper that you mentioned that talks of AI as a social technology. But I actually wanted to ask, I'm going to move the axis a little. We think of AI, I grew up in the era where, winning at chess was a big deal, winning at Go is a big deal. What's really happened, I think, is if I think like a physicist, with the establishment of these large language models, for the first time we have the equivalent of a super collider or a space telescope. We have an instrument of inquiry, which we never had before. And I wonder if there aren't other instruments of inquiry that would change our knowledge of the field so we could ask certain questions. Rather than us sort of incrementally working on puzzles, are there instruments we need to be building? And is there something other than a large language model that we might care about? So, over.
That's interesting.
So I'm going to complicate your question even more, Bill, which is to say that I think large language models are not only instruments. They are instruments for some purposes of some research. They are also, I think, an object of study, which for the first time, AI has a knowledge base that is worthy of really deep study. Usually we coded those up ourselves, all right? We knew what was inside of them, and it was the algorithms that we were focusing on. And what we've got now is we've got this incredibly big knowledge base and implicit reasoning algorithms within that we're trying to study as one massive unit, and we're faced with the same problem that neuroscientists have of really not understanding what's going on in that. So it's also an object of study as well as a new instrument.
Yeah, and I would just say that it's not just the AI piece that's an object of study, it's actually the entire pipeline. right? Starting from like what data, right? Should AI even be used for this problem? Like what is the data, right? How was it vetted? What were the assumptions that went into the models and all of that, all the way to the end. So I think we are really now studying this object, if you want to call it, but it's the entire decision pipeline.
All right, front speaker.
Hello, my name is Lucy Fortson. I am from the University of Minnesota, and I actually am an astrophysicist that uses some of those instruments. My question, and I also was a co-lead of a recent convergence consortium meeting here in Washington, D.C. from the CCC on the convergence of computing and citizen science. My question is, as a scientist, and Yolanda referred to this a little bit, is the excitement that we're seeing in the scientific community about building foundational models. What I want to ask is, there's this sense that science is, we scientists are sort of using AI as an application. But what can we as scientists contribute to AI research? Are there things that can uniquely be done by science that you can't quite get with the data sets that have been trained for these large language models? What can science contribute to AI research?
So that question is a little bit related to the one that Bill just asked.
Yes, exactly.
Are there different tools we can bring to bear in the AI world?
So, yeah, so if I can take this. So this is actually a colleague of mine, Professor Carla Gomes at Cornell, really uses AI, so he has a program, AI for Scientific Discovery. What science can bring is that scientific knowledge and reasoning about, material science or reasoning about some physics domain. Science is driven by knowledge that is captured in laws and principles. It's actually not really data. So it brings a very interesting problem to AI in the sense that, okay, we are good at taking lots of data, where AI systems are not so good at, reading about Newton's laws and reading about relativity or quantum physics and using those equations to think about the topics. So there is interesting work there of how do you get the knowledge in physical laws or just human knowledge. It could also be medicine and biology, healthcare. How do you use that knowledge in your system and reason with that? And actually, it brings a whole new angle to the purely data-driven approach of deep learning. And it turns out you can integrate it. So it brings new challenges to AI to build. I guess following up early question, where you still need something quite different than the transformer architecture. So you need something quite different than a language model.
It's difficult to make predictions, especially about the future. Of course, I think he meant accurate predictions. Even I can make the other type. Nevertheless, I can confidently say that whatever unfolds as we continue this partnership between academia and government and industry, it will be an exciting adventure, one that today's wonderful set of panelists have explored as they've shared their deep insight and wisdom. So let's thank them once more for their participation today.